Okay, the other function we're going to look at here is logarithmic functions. Logarithms are the inverse function of an exponential function. You've seen this before, the exponential form looking like this. If you convert that to log form, it looks like this. The common theme here is your base. Okay, call the bigger number in an exponent the base. When you have a log, you also have the same base uh, in there. So the a is the same number in each. So you should be able to flip back and forth between exponential form and log form. And it does equal the same thing if you start with something that was like, say, 2 to the 5th power equaling 32. You should be able to convert that to log form, uh, which would look like this. You'd have log, okay? 2 is our base, and so 2 would become your little number here. Uh, the whatever your answer is, that would be the 32 here, equaling whatever the exponent is. So you should be able to go back and forth between these two forms. And if you check them with your calculator, again, they should be equal to each other. Okay, so knowing that, since it is inverses of each other, these would be true. If you take a log where the base number matches the base of the thing you're taking the log of, that would essentially cancel out and you'd just be left with x. Same would be true if you did an exponent where the exponent was a log that had the same matching base number. This would also equal x. So anytime your base numbers match up, it would just be equal to whatever you're taking the log of with the exponent, or in the top case, whatever the exponent would be your answer. Okay. Also, you should know the three basic laws of logarithms that you looked at starting back in Algebra 2. Anytime you are multiplying with logs, you can split that into two logs with the same base where you have the two things being multiplied equaling there. An example of that would be like if you had log of, let's say, I don't know, 80, okay? We know 8 times 10 is 80, so you could split that into log of 8 plus log of 10, and those should be equal to each other because 8 times 10 equals 80. If you are dividing, that's the same as subtracting two logs with the same base. So if you had, we could go 80 again. Okay, log of 80. That would be equal to 80. We could write the same as I don't know, 800 over 10. And so log of 80 should also be equal to then log of 800 minus log of 10. And those should be equivalent to each other. So anything that you could, any way you could change this to equal something where it's dividing, you could then split it into two being subtracted. This one, last one, is probably the one we use the most when you're evaluating with logs. Anytime there's a power or exponent of your log, that's the same as taking that little exponent, okay, in this case, that r right there, and you can move that out in front of the log, and it's equivalent to what we have here. Okay, so as you can take and move, anytime you got a log and there's an exponent on there, you can move it and multiply it out in front of the log, and they're equivalent. All right, so let's do some simplifying of logs here. Let's try to evaluate this one without a calculator here. We got log base 5 of the square root of 5. Well, one thing we know, anytime you're taking a square root, that's the same as a power of 1/2. And so we could write this as log base 5 of 5 to the 1/2 power. Using that log or that property we just had, anytime there's an exponent here, we know we can use log properties to move that as a number being multiplied. Okay, so now we got 1/2 times log base 5 of 5. Well, what did we say is always going to be true anytime you got the base matching this? It should just match whatever the exponent here, it'd be 1. And so this is just this part right here should just equal 1. So we got 1/2 times 1, or 1/2. Just to show you that that is in fact true, watch what happens when we put, we can try this one with the calculator. First, to do logs with the base on your calculator, if you hit the math button and scroll down, usually towards the back here, this one that says log base, that one you can enter it in. So if you do log base, enter base of 5, and then we got square root of 5. This should give us 1/2 for the answer. Yep. Okay. What I want you to do next here, pause the video, see if you can evaluate this next one without using a calculator. If you have to, then try using it, but see if you can do it without it first, then see what you get. All right, let's check it out. Log base 2 of 80 minus log base 2 of 5. Since they have the same base here, remember subtracting would be the same as dividing. So we could change this into log base 2 of 80 divided by 5. 80 divided by 5 is the same as 16. We know 16 we could also write as log base 2. 16 is the same as 2 to the 4th power. Now that we have an exponent, we could move that as a number in front. I got 4 times log base 2 of 2. Anytime the base is going to match this number, that's going to be equivalent to 1. So we got 4 times 1, or just, looks like the answer comes out to be 4. If you got that without a calculator, that's pretty good. If you had to check it with the calculator, try to at least think of these things as you're going through. All right, some other things with logs. Natural log. Anytime your base number is e, that natural number, that's written as natural log. It has its own notation, natural log of x. So anytime you see this ln of x, really know that it's logarithm of a base e. Okay, that comes in handy when you start using or trying to find inverses of stuff. Like this problem. What is e to the 5 minus 3x power equals 10? Okay, we want to evaluate this. Well, how do you undo e? Natural log. Okay, that's why even when you look on your calculator, okay, they're the same button next to each other there. We want to undo this by taking the natural log of both sides. Okay, doing that, now that we have a log, we can take our exponent and move it down in front. So our problem now becomes 5 minus 3x times natural log of e equals natural log of 10. We know natural log of e really is log base e of e. So if these are matching up, that's equal to 1. So this is equal to 1. But since it's times something, timesing by 1 doesn't really change anything. So our problem basically is just now this. From here, we should be able to solve minus 5. So we got natural log of 10, take away 5 here, divide by negative 3, and we can get our answer. So now it's just a calculator problem to see what that evaluates to. Let's plug that in and see what we get. So we got natural log of 10, close that parentheses up, minus 5. I'm going to hit enter here, so it evaluates that part first, and then hit divided by negative 3. And it looks like our answer comes out to be about pretty close to 0.9 here. Looks like x is very close to 0.9. So that would be the answer. Okay, you've done that solving before, so see if you can do this one, solve out what this would be. So pause the video and try this one. All right. Let's see how far you got. The first couple steps you for sure should have gotten here. Subtract 1. And we got 8. Then looks like you got to do some division here. So you got natural log of x equals 8/6, or you could simplify that down to 4/3. Here might be the step though if you got stuck. What do you do here? Well, remember, what's the opposite of natural log? E. So here you could use that very first thing we talked about changing from log form back to exponent form. Would be very helpful here, being able to switch back and forth between these. We got a log that we can't evaluate. If you switch it to the other form, you can certainly solve this one. Because remember, what is natural log the same as? Log base E. So let's apply that to this problem. If you really think of this as log base E, then to solve that, you're changing it into exponential form, which would be x equals e to the 8/6 power. So if you evaluate that on your calculator, that should solve it. So just think, another way to think of it, if you got ln here, how do you undo that? E. E undoes ln. And so now you just plug that in your calculator to see what the answer is. Calculator, your E button is again right by the ln button. So if we hit second natural log, type in 8/6 or 4/3. We got our answer here, about 3.8. So x is very close to 3.8. Now, when you are doing this, if it's a homework, doing this is fine. If this was a U of M test, you'd want to keep this as your answer because that is considered the exact answer. And on the U of M test, we'll talk about as we come up, you want to leave the exact answer. So you'd want to either answer with e to the 8/6, or that also simplifies the e to the 4/3 would be a good answer too. All right, last one. If you get one of these where you might have to combine some logs, again, go through and do the properties, use those. Here we'd want to check, is there any numbers in front of any of these logs, and deal with that first. The middle one does, and so what you'd want to do is take that, use that exponential power, move it up here. And so you got natural log 45 minus natural log of 3 squared minus natural log 1. We know 3 squared is the same as 9. Okay, they're all natural log. They all have the same base. So now what does subtraction turn into? Division. So let's move left to right here. If we combine these, that'd be the same as natural log of 45 divided by 9, which is the same as 5. Apply that same property one more time and we can get to the final answer here. The subtraction again turns to division. 5 divided by 1 is still 5. So exact answer would be natural log of 5. And again, you could find the approximate answer if you wanted. On the U of M test, we're always looking for exact answers when possible. All right, I want you to keep working on this assignment that you got with functions and logarithmic functions and complete that.